Welcome guys to another episode of Physics with Prime. In this particular class, we are going to be talking about equilibrium of forces, but we are not going to be going broadly into that. I'm going to quickly talk about Lami's theory, which is actually a concept that most students find very difficult. So we are going to explain that and solve some examples. Okay, so first things first. When we talk about equilibrium of forces, remember that there is a condition for equilibrium to hold. Equilibrium means a state of balance. So there is a condition for equilibrium to hold. And what are those conditions? The first one is that the sum of forces in one direction must be equal to the sum of forces in the opposite direction. That is for forces. And then the second one says that the sum of clockwise moments must be equal to the sum of what? Anti-clockwise moment. That is for their what? Moment. But we are talking about the equilibrium of forces. So one of the theories that is used to analyze equilibrium of forces or forces that are in equilibrium is Lami's theory. Okay? Now, if we have a system of three coplanar forces, when I say coplanar means that they are what they are. Coplanar means that they are on the same plane. They are acting on the same plane. So forces that are coplanar means that they are acting on the same plane. So if I have a system of three forces that are acting on the same plane, so look at this. So this is these are the forces. Let's call this F1, let's call this F2, and let's call this F3. So these three forces are acting at a single point on the same plane. Now, for us to be able to apply the Lami's theory, Lami said that you must have what we call a free body diagram, and that is what I have just drawn here. So we are going to have a free body diagram. Then we need to represent the angle between all the forces. So let's assume that the angle between these two forces is theta. Let's call the angle between these two forces as theta. Then let's say the angle between these two forces is alpha. Let's say that the angle between these two forces is beta. So we know the angle between individual forces, as you can see on the board. Now, once you have a diagram that looks like this, Lami's theory now said that if you pick one of the forces, let's say we start with F1, and divide it by the sine of the angle it is facing. Looking at F1 now, what angle is facing F1? It is alpha. So the angle alpha is facing F1. So I will say divided by sine alpha, it is going to be equal to, take the second force. Let's say we take F2 and divide it by what angle is facing F2. You see, it is beta. So divided by sine beta. Divided by sine beta, and it is also equal to the third force, which is F3 all over sine what now? Alpha. Okay, sorry, I have here should be theta and not alpha. Remember, F3 is facing what? Theta here. Now, looking at the diagram we just drew here, alpha, beta, and theta are all they are not acute angles. Okay, they are not acute angles. They are what we call obtuse angles, meaning that they are more than 90 but they are less than 180. But we need to convert them so that they will look like acute angles whenever we are solving. So what do? We just simply change this to F1 over sine 180 minus alpha to make it an acute angle. Okay, and remember that sine is also positive in the second quadrant, so we don't need to put any sign. And this is also equal to F2 over sine 180 minus beta, and also equal to F3 over sine 180 minus theta. So you can use it this way, or you can still stick with this first one that we have here. Anyone that is more convenient for you, no problem. But the reason why I had to write down this one is because when you are solving a question in JAMB, most times you need the angle as an acute angle so that you can be able to get the value that it represents. So make sure that you know how to convert. If you use it this way, no problem. If you use it this way, no problem also. Okay, so we are going to solve an example or two to illustrate what we have just said.